You ever look at an old math worksheet and get this weird feeling? A little bit of nostalgia, maybe? Well, today we're going to crack one of those open and find some surprising genius hiding right inside.
Yeah, seeing something like this, it probably brings back a flood of memories, right? But here's a thought. What if I told you this isn't about memorizing rules at all? What if it's actually a logic puzzle, just dressed up in numbers? All right, let's just dive right in. The goal here is to completely reframe how we think about arithmetic. We're going to stop seeing it as a chore and start seeing it for what it is, a seriously powerful and, yeah, elegant set of tools for making sense of the world. So to do that, we're going to take a little tour through 5 key ideas. And these ideas are going to peel back the curtain on the beautiful system that's hiding just under the surface of the math you do every day. Okay, first things first. Before we can start, manipulating numbers, we kind of have to appreciate what a number is. So let's break down its most basic structure. You see, a number isn't just a string of digits, right? It's an entire system. Look at that 1 all the way on the left. That's not just a 1, that's 1 million. But the one on the far right, that's just 1. See? Its position, where it sits, gives each digit its power, its meaning. This whole place value thing, it's the foundation for literally everything else we're going to talk about. Okay, so we've got our building blocks. Now let's talk about the rules of the game, the blueprint that tells us how to put them all together.
When you see a problem like this, it's not a suggestion, it's a strict set of instructions. It's a logical sequence you have to follow. Those little plus and minus signs, they're telling you not just what to do, but the exact order you have to do it in. Now, for addition and subtraction, the rule's pretty simple. You just go from left to right. And this shared agreement, this universal language is what makes sure that no matter who you are or where you are, we all get to the exact same correct answer.
But let's be real. In the everyday world, you don't always need the perfect answer, do you? A lot of the time, you just need to be close, and you need to get there fast. And that's where our next superpower comes into play. Now, some people think estimation is just lazy math. No way. It's actually a really sophisticated tool for making quick, smart judgments. It's all about knowing your numbers so well that you can tell when being super precise just isn't the point. And this right here perfectly shows the trade-off. The one on the left, yeah, you're going to need a calculator or some paper for that. But the one on the right, you can probably do that in your head in, 3 seconds? It's all about choosing, do you need precision or do you need speed? So yeah, getting to this exact number takes time. It's perfectly accurate, sure, but that's not always practical when you're just trying to make a quick call. But the estimate, boom, it gets you in the right ballpark almost instantly. And honestly, in so many real-world situations, just knowing the answer is around 120,000 is all the info you really need to move forward. Okay, now for the really fun part. This is where arithmetic stops feeling like math and starts feeling like a logic puzzle. So let's put on our detective hats and find the clues hidden inside the numbers. Take a look at this. The question is totally different now. It's not just what's the answer. It's what numbers have to go in those blank spots to make this equation true. It forces us to think backwards. So where do we start our investigation? All the way on the right, in the ones column. It's the easiest piece of the puzzle. 8 minus something is 7. Well, that's easy, right? It's got to be a 1. And just like that, we have our first clue. And we just apply that same exact logic one step to the left. 9 minus what gives you 6? It has to be 3. See what we're doing? We're just building the answer, one logical piece at a time. And we just keep doing that for each column. 5 minus what is 1? 4. 4 minus what is 2? 2. So we've taken what looked like a complicated mystery and solved it with a bunch of simple little deductions. The missing number can only be 2,431. There's no guesswork at all. It's just pure logic. All right, finally, let's talk about the elegant recipes, the algorithms that let us tackle really big calculations without getting totally lost in the numbers. I mean, when you boil it all down, what even is division? It's just asking a simple question. How many times can this smaller number fit inside this bigger one? That's it. The real genius is the step-by-step process we came up with to answer that question, even when the numbers get ridiculously big. Think about something like long division. It's really just a recipe, step by step. It lets you take a big, scary-looking problem and break it down into these tiny, manageable little bites. How many times does 4 go into 18? Okay, now what's left over? Bring down the next number. Let's do it again. It's such a powerful and reliable way to handle complexity.
So let's wrap this all up. What's the big takeaway? First, arithmetic isn't just about memorizing rules. It's about logic. Second, estimation is an incredibly practical tool for your everyday life. And third, every single math problem is really just a puzzle if you know how to look at it.
And that kind of leaves us with one last thing to think about, doesn't it? If something as basic as grade school math has all this hidden elegance and logic packed inside, it just makes you wonder what other amazing ideas are hiding in plain sight in all the other subjects we thought we already had figured out.